So in this video we're going to be learning about negative indices. So this is anything of the form a to the power of negative b. Okay. So how do we define a negative indice? It's a little bit of a weird thing to think about because we know that, well, if we were going to have 2 to the power of 3, that's just 2 times 2 times 2, right? It's 2 times itself with 3 2's here, okay? 3 refers to how many 2's there are. But if we have 2 to the power of negative 3, what does that mean? What does that mean? 2 times itself negative 3 times? Doesn't really make sense. So this is where in your mathematics you'll have to go from this sort of way of thinking about indices to a slightly different way of thinking about them. So here's the property. A to the power of negative b is simply the same as 1 over a to the positive b, okay? So this negative symbol in the power essentially has an inverting property, okay? We say this is inverted because it's 1 over itself, okay? So we can get rid of this question mark now and apply this. So this would simply be 1 over 2 to the power of 3, which is 1 over 2 times 2 times 2, which of course is 1 over 8, okay? So we can see the similarity between these two, okay? Here we had 2 times 2 times 2, here we had 1 over 2 times 2 times 2. It's a little bit of a strange thing to think about because we're used to this minus sign referring, like making the result negative, right? But in this case, a minus sign in the power actually inverts it. So this is still a positive number, right? This equaled 8, okay? 2 to the power of 3 is 8, but 2 to the power of negative 3 is 1 over 8, okay? They're both positive numbers. So that's quite interesting when you think about graphing these things. How can you apply an indice to a number to make it negative, to make the result negative? We might cover that in a future video, but graphing these exponentials can get quite interesting and give some interesting results. Okay, I might just do one example now of doing this in conjunction with some of the other laws. So let's see if I can think of a slightly complicated example. We'll start with, let's go with 4x to the negative 2. That's all to the power of 3. Okay, and we're going to multiply that all by x squared. Okay, so this could be a problem that you would get in a test or something. This looks quite messy, but you'll see that this actually simplifies quite nicely. Okay, so let's break this into parts. First part, I think we got to deal with this indice here. Okay, so we're going to distribute that throughout this bracketed term. So 4 to the power of 3, well, 4 to the power of 2 is 16. 16 times 4 gives us 64, okay? So we'll leave the x squared there for now, but here we now have 64. And this, we can use our property from the previous video. This is just negative 2 times 3, so we have an x here. Negative 2 times 3 is negative 6, okay? So we've got x squared, 64 from the 4 to the 3, x to the minus 6 from the minus 2 timesing with the 3 from our property from the last video, okay? This can be simplified again with one of the properties from the first video. So we'll see here that, I'll just rewrite this slightly. We've got 64 times x squared times x to the minus 6, okay? We can clearly see here that we have two numbers with the same base multiplying each other. So remember, we can add the indices here. So we can write this as 64x 2 plus minus 6, or minus 6 plus 2 gives us minus 4, okay? Now in a lot of tests, they asked you to give the result in positive indices. That's okay, because we have this property up here that tells us that if we have a negative indice, we can write it as 1 over the version with the positive indice. Okay, so we can write this as 64 over x to the power of 4. Okay, and that would be a really nice final answer for simplifying this. It's got positive indices. Okay, hope that was helpful. It was nice to do an example to see how these things can kind of come together. We'll do some more complicated ones as well. And in the next video, we're going to cover fractional indices, because that can get a little bit tricky. All right, thanks for watching. Hope that was helpful.